be discussing another past board exam problem in hydraulics and geotechnical engineering. So this is actually in a rotating vessel problem. So the problem states an open cylindrical tank 1 meter in diameter, 2.5 meter high is 3/5 full of water. So we have to determine the angular speed in revolution per minute if the water will just touch the rim. Second, the vortex will just touch the bottom. Third, the base uncovered within 20 cm from vertical axis. So in this type of problem, we actually need to visualize it, and we have to do it on our own because we cannot expect that during exams the examiner will give you the illustration to solve the problem. So we have to interpret the problem uh, by ourselves. So the problem state it has uh, a open cylindrical tank 1 meter in diameter and 2.5 meter high. So you can draw it like this: open cylinder with a diameter of 1 meter and a height of 2.5 meter. Now the depth of water inside our cylinder is actually 3/5 of our height, or 3/5 of 2.5, which is equal to 1.5 meter. So the height of water in the tank is just actually 1.5 meter. Now we have the D, and it has a value of 2.5 minus 1.5, so that will be equal to 1 meter. Now the water will just touch the rim for our question number 1. So for that to happen, we can actually conclude that the paraboloid will just touch the rim and there will be no liquid that will be spilled. So by drawing, our paraboloid will look like this. Now it is rotated on the vertical axis. So this is our height of our paraboloid. Now that HP is actually equal to 2 times our D for the water will just touch the rim. So meaning there will be no liquid spilled in this condition. So HP is 2 times 1. HP is equal to 2 meter. Now we have to remember our formula for our height of paraboloid is equal to omega squared r squared over 2g. So our height of paraboloid is 2, and then 2 is equal to omega squared times r. Our r is, since our diameter is 1 meter, r is 0.5 meter squared over 2 times g, or the acceleration due to gravity. So 2 times 9.81 is equal to omega squared times 0.5 squared. So for us to determine the value of omega, divide both terms by 0.5 squared. So cancel. So you'll be left with omega squared is equal to 2 times 9.81 all over 0.5 squared. So for us to determine our omega, we have to extract the square root. So omega is equal to the square root of 2 times 9.81 times all over 0.5 squared. So that is equal to square root of 2 times 9.81.5 squared. That is equal to 12.52 radian per second. So we have, since our problem, it states that in it should be in RPM, so 12.52 radian per second in there are 2 pi radian in 1 revolution, and there are 60 seconds in 1 minute. So cancel radian, second. We'll be left with unit of revolution per minute, or RPM. So this will be equal to 119.56 RPM, or revolution per minute. Now another faster way of converting this one is by multiplying uh, this value by 30 over pi. So that will also result to 119.56 RPM. That is for question number 1. Now for question number 2, the vortex will just touch the bottom. So we'll draw it again. Now this is 1 meter, 2.5 meter, um, two, this is 1.5 meter, 1.5 meters, this is 1 meter. So the vortex will just touch the bottom. So we'll draw it like this one. So the height of paraboloid will look like this one. So this is the height of paraboloid. Now this is rotated at its vertical axis. So from our illustration, we can notice that the height of paraboloid is equal to the height of the tank is equal to 2.5 meter. Now going back with our formula for our height of paraboloid, we have 2.5 is equal to omega squared radius, still 0.5 squared, over 2 times 9.81. Now 2.5 times 2 times 9.81 is equal to omega squared times 0.5 squared. So both divide both sides of the equation by 0.5 squared. So cancel. So we'll be left with omega squared is equal to 2 times 2. No, not 2 times 2. That will be equal to 2.5 times 2 times 9.81 all over 0.5 squared. So for us to determine the value of W, or the omega, we have to extract the square root of this one. So omega is actually equal to 2.5 times 2 times 9.81 over 0.5 squared. So that is equal to 14 radian per second, and we have to multiply it by 30 over pi for us to determine the value of in RPM. So that will be equal to 133.7 58 RPM. Now